This presentation will cover the new unary negation feature in NORMA. This has been a long time coming. Should have been done probably before most of the gray was in my head. Hopefully we've done this in a way that doesn't overly impact your day-to-day life. There will be some new features. There will be some changes in generated DDL. Hopefully by the end of this presentation you'll understand why that needed to be done and how to leverage all the new capabilities that are in the tool. So this presentation is meant to be relatively short. For now, I want to know why we're changing the unary fact types, what was wrong with them to begin with, and what I mean by the notion of a unary negation. We'll also look at the implications on relational mapping and a few tips on what it will take to open prior models. You'll see some visual changes on the unaries as soon as you open a prior model, and you need to know how to deal with those. So the old mechanism for storing unary fact types was actually a binary fact type under the covers. There was a Boolean true-false value. We automatically created a value type for it. And that is what controlled your true or false state on the Boolean. This mapped great to relational models. It didn't, unfortunately, map well to logic. The problem was, instead of saying, well, if this object plays this role, so if a person plays the person has person name role, the person role, and person has person name, they have a name. In this case, you didn't actually know. It wasn't only that you played the unary role, you also had to play it with a true value, so you had to check the far value to make any sense of the logic. This caused all sorts of problems with constraints. So when we constrained against a unary, we could only constrain to the true state. We had no way of referencing the false state. For example, you couldn't say, well, I know the value is false, and when it's false, I want a subset constraint on that. That constraint was not actually possible in the model. You couldn't specify them as mandatory. So even if look, I must have either, you need to tell me, is it true or is it false? Don't give me a null. I don't want a null state. I want to explicitly know whether it's true or false. You couldn't do that. Objectification applied to both states. This was bizarre, frankly. So if you have, action is allowed and action is disallowed, which are the true and false values of the same fact type in the binary world, your objectification just means known state. It doesn't mean allowed or disallowed. So then anything applied to the objectification really doesn't make sense either, because you're saying, well, yeah, I can take these two exactly opposite states and I'm going to objectify them as the same object. That doesn't really make sense. The logical expressions also caused a lot of problems when you get into the derivation rules and other things that you'll mostly be exposed to in NORMA Pro. So given an x and not x dot a, right, meaning not the unary a on an x object, doesn't mean that it's known to be false, right? It could also be null, because not, x dot a means true. You have two other available states, false and null. So not xa, that doesn't mean it's exactly false. So you can't actually say in the current logic in the old system that says this value is known and explicitly recorded as being false. That's the problem. So I mean, why really, it's not on the slide here, but why do we care on this? So when you're dealing with a typical business domain, it's very common to say, look, there's a, what's the answer to this question? It's a yes/no question. Is it yes? Is it no? Or does the person just not know? And you want to decide up front which of those values you allow, right? Do they have to provide a value? If so, give me a yes or a no. Is the false always just the opposite of the true? Then just fine, leave it as a true only, so you get true or null, which is really equivalent to true and false in that case, because you can't explicitly say false. So from a linguistic standpoint, which is of course what ORM originated as a linguistic mapping mechanism, it doesn't make much sense to say, well, gee, I have a unary, it's true, false, but yeah, you can't really say false. You have to introduce another unary. You've got to put an exclusion constraint between them. You might want a disjunctive mandatory between those, and you can put your own unaries together on your own in order to be able to say true and false. So, I mean, we really don't want that, because from a domain modeling perspective, it's horrible. But from a logic perspective, where we ended up with is this other bad thing as well, right? Where we have a unary with two states, where we really only wanted one state on a unary, and to be able to distinguish between the true and then the opposite false state. So that's where we're going. in the new unary representation, a unary really is just a unary. It's a fact type, has a single row on it. There's no binarization behind it. You can then associate that positive unary with a unary negation, which is a completely separate fact type. Now we've added an ownership relationship in there, so you know that the negation is paired and explicitly paired with the positive fact type, which has the true value. The other negation is just a normal unary fact type. If you don't pair the two, it actually has a true value, even though it's known to be the exact inverse of the other one. You need them paired so you know to do things like when I map to a relational model, I want one column, I don't want two, right? Similarly, when you map to a language with a Boolean property on it, you want one value, you don't want two for these things. So the backing elements exactly map what we're talking about with a unary negation. Automatically, you get the second unary, the negation. You also get an exclusion constraint between the unary roles and the two fact types. If you decide to be a true-false, explicit and mandatory, you also have a mandatory constraint on there. This is all controlled through what's called the unary pattern property. There are three main patterns here. True or unspecified means you have one unary fact type, you don't have two. True, false, or unspecified means you can explicitly put the false value. True, false, you add a mandatory constraint. So I'll show these on the next slide in the demo from the tool. You can also have a true, false, obligatory state, which just means the mandatory is a deontic constraint, so it's mapped the same as the true, false, unspecified. When these are on the diagram, you'll see as soon as you put a unary negation on, you'll see an additional notation on the unary fact type. It's the same size as a typical mandatory constraint on the role, except you'll see a plus or a minus. If they're paired and mandatory, you'll see the mandatory color with the plus or a minus in there. So if you see a unary fact type now with a plus, it means there is a negation for it. This is the positive side, there's a negative side. If you see one with a negative, it means it's the negative of a negation. There's nothing actually connecting the two on the diagram. We looked at doing that, but it's very messy, right? There's a lot of extra bulk that you would need to put on the diagram that looks similar to external constraints, right? To show that these two are together. The proximity on the diagram really does about the same thing. You would have had to make that notation directional because you need to know which one is positive, which one is negative. And if you only have one of those out there without the other one, you wouldn't actually know which is positive and which is negative, or have any indication that you're looking at a negatable unary. So went with the notation that is just the small plus and minus in the mandatory constraint space on the unary. If you flip is mandatory on the context role, it will make the fact type, the unary fact type, negatable. It'll add the negation, and it will flip on the mandatory. After that, if you toggle, you'll just change the constraint state. If you want to get rid of the negation altogether, you have to use the unary pattern property. Unary pattern is actually what's controlling. The other ones just set that property. So let's go ahead and look at that in the tool, and then we'll get into more of the editing gestures that can be used to modify these unary fact types. Okay, here we have a brand new empty ORM diagram. Let's put a unary fact type on it. So if I say action, let's get rid of the error, is allowed. Now I have a normal unary. If you look at the unary pattern here, it says true or unspecified. The unary pattern only shows up for unary fact types. This means that there is no backing negation for it. The only possible values are true and unknown. This will be limited and constrained in the relational mapping and other mappings to only allow a true value. You can't put false in. So if we now change this, let's go true, false, unspecified. Hey, now I have a separate mapping here. Okay, I've added this little plus. You can zoom in if you want to see the plus. Okay, there's your bigger plus. Okay, let's just stay big here. So the plus is there. It's slightly offset with the backing line, so it doesn't look like just part of it. And that means that this is the positive unary, and there is a negative or a negation associated with it. So if we go and look at what's behind here in the model browser, select in model browser, we will see one role, right? It's true unary, and a negation fact type. This just uses the tilde to get a default name for it. This is just like its parent fact type, except it's associated as the negation. And here we have the implied constraints. So if you look at the negation fact type, it also has the unary pattern. And you know you're on the negation because it has this read-only property called unary negation true. So this sets the unary pattern on the positive fact type, not the negative. So let's just go ahead and pull this out so we can see what it looks like. Okay, so now you have the negative sign to go with the positive sign. And if I pull out the exclusion constraint, I can see that. At this point, I can hit these and say is mandatory. And now I've changed to a mandatory. So this actually means there's a disjunctive mandatory. It's not that each of the roles are mandatory. So you can tell that difference with the plus and the minus in there. This is the mandatory for the pair. The other thing to note here is that this doesn't have a reading. So you will not get an error that says you need a reading on this until you objectify. Once you're objectified, you need a reading on both fact types because at that point they're treated separately. So let's go ahead. We can do it here if we want to, or the other one. Notice the tilde. So this is similar to the forward slash on a reverse reading for unary. And we can say is disallowed. Okay, and now we have the forward and reverse readings for that. Okay, that's really the basics. You've got the two constraints. You have the plus and minus displaying. You can also do slightly different unary patterns. So you can do a obligatory. Right, this is drawn slightly differently. You've got little notches around the outside. That's for printing reasons where you can't tell the difference in the constraint color. You can also put a pattern on here. So if you go true, this is especially useful for true false. So if you say I want default false, that means when you create the object in the database, it will fill in the false value for you. So it's not quite as hard to map in. Now beware, we can only do default values if you're a non-absorbed object. So if you absorb a subtype, you put a unary on, they say, hey, the default, there's really nothing that the database can do about that because the row will exist and must be able to exist without that value in there. So the defaults are useful, but only for types in the primary table. Okay, that's the basics. So these are two fact types. You can do normal things with them. You can objectify them. You can unobjectify them. You can put constraints on them. You can reference either fact type when you're doing derivation rules. And you can be very explicit now about what you mean. When these map, they will go to a single column. Extension manager. Let's just turn everything on. Okay. Alrighty. So now this will have one column called is allowed. Okay, so they collapse in there. Now, if this is a unary with a that only has the true false on it, the unspecified, and you go back here, you'll actually see a slightly different state. So instead of saying Boolean, it says it's optional and it's true. So that's how we're showing the true only state. Of course, true is not a real SQL data type, but these are pseudo types anyway, so that lets you see what's going on there. Okay, those are your basics. We'll come back later to this to see some more of the editing gestures that are possible. So as a review on what you just saw in the diagram, when you change the unary pattern, you get a new unary fact type, which is the negation fact type. You get an exclusion constraint. If you then make it mandatory, use one of the required patterns, true, false, without the unspecified, you also get a mandatory constraint, which is coupled as an exclusive or constraint in the tool. You see all these as children of the positive unary, so you're not going to see a separate entry in the model browser for the negation. You're also not going to see the implied constraints listed with your external constraints as exclusion and disjunctive mandatory constraints. Your verbalization will always show the exclusion constraint, which might be XOR, so that will change the verbalization. That's a really good indication, just looking at it, that you're looking at a paired unary pattern. So you have a positive and a negative. You'll see both of those verbalized with the fact type itself. Normally, exclusion constraints don't verbalize with the fact type. So clearly, when you're working with these, you don't want to have to go to the model browser to pull a negation shape out. So there are other ways to deal with these. There are also several other editing gestures in the fact editor and the reading editor that make it easier to work with these things without actually adding shapes. Most of the time, you're not really going to need the negation shapes on the diagram, and the positive one will do everything you want to. Only when you're doing objectification and additional constraints is it going to be really useful to have that other shape on there. It's easier to just look at these here instead of going through the slide. Obviously, you can pause the slide and look through the details if you'd like to. Before I showed you that you could go to the model browser here and drag this out, drill down, find your unary negation. That's a little annoying. So if I don't have this shape here, I can just click it and go drag unary inverse. Boom, and now I have my shape. So placing the shape on the cursor is something that's been done in a couple other places as well in this new rendering of the tool. If I objectify a fact type, objectify fact type, I can click on the role and I can pull out the link fact type. So to do this, you used to be able to do it, but you had to go to the model browser again and find the implied fact types from the shape. There's actually a similar gesture down here. So if I go down here, let's start with action and just put a new one, R. Okay, so commit auto create shapes is your old command. That's a control enter. That's the one that's been there forever, and you love it or hate it, that's what it is. There's a new command called alt enter that does exactly what we did before. So it alt enter, you can click, it creates the shape for you. Right? And if you have a brand new fact type or multiple shapes, you can do, for example, I can do B, C, and D are subtypes, and I can click 3 times B. That didn't work. B, C, D, alt enter, move, click, 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 and now we're back to normal mode because those are gone. So anyway, that's kind of a nice new little thing that makes it a little easier to add shapes. The fact editor is really useful on a complicated diagram that's very busy, and a good new editing gesture. So these also have mechanisms to get to them in the reading editor. If you look at the reading editor, you'll see if I have a negated unary open, it has a unary negation there. Unary negation readings, and similarly, I can get the positive unary readings with the negation selected. So you can actually edit the readings for either fact type from either location. So those are your primary gestures: reading editor, new commands to drag the fact out, and then the fact editor with the tilde notation, which gets you, which is frankly where I add most of the unaries. Now, once you've made it a unary negation, you're not going to be able to get rid of the unary pattern like that. So just putting the tilde with nothing after it will remove the reading and won't remove the pattern. If you really want to get rid of it, you have to go over here and change the pattern. So in this case, if I go back to true unspecified, the shape I was on actually disappears because I've deleted the unary negation. So with this change, objectification of a unary fact type is much more useful, simply because there are 2 separate states, right? So if you have an action, an allowed action, and a disallowed action, they are separate objectifications, as is logically correct because they do separate things. If your unaries are not objectified, they will always map to a single value. It just collapses them into a Boolean with the true-false state. However, once you objectify, they separate. So in that case, for example, if you objectify the positive unary, the unary negation will actually have a true value because it is now a standalone column, for example, in the relational mapping. I want to do just a touch more on this topic with relational mapping. Otherwise, you're going to get in here and go, where are my new columns coming from? What happened to my unary columns, etc. So a paired normal unary just maps to a Boolean column. As I've said, if it's not paired, meaning it's just a true null, it will map to a true value. If it's objectified is where things start to get a little interesting. So we've also added features for the subtyping, or a specific feature with a is subtype column. So previously, if we found that there was no evidence that a subtype existed on an absorbed column, we just said, go away, you can't do it, and we forced it to be separate. Now we will actually generate an is subtype column. So if you see a is and then the subtype name, it means that an absorbed subtype can't be identified as that subtype without an additional marker. So for example, if you play no mandatory roles, you need an is subtype column to know your column. If you play no roles at all as a subtype, there needs to be something that says I am of this subtype. So is a subtype is actually a fairly tricky concept in a lot of cases to figure that out. It is often fully derivable, meaning I have a mandatory role in there. So if the supertype plays that role, and which maps to a column in the database, then it has to be of that subtype. You can also be asserted only, meaning there's absolutely nothing else on there that can indicate that you are a subtype. And then there's in between. I play mandatory roles, or sorry, I play only non-mandatory roles. So I know I'm of that subtype if those roles are played, but if you don't play those roles, you need another marking that says, well, I am of the subtype. So if this sounds a lot like a unary state, it really is. It's a Boolean bit state that says, hey, I am of that subtype. In fact, now the unary objectifications and subtypes basically have the same mapping. So when do these columns show up? We do an analysis if there are no mandatory roles played by the objectification or by the subtype, including references to it. So it's not only in the same column, which would have been a stricter interpretation, but is also, overly strict in some cases. So if there's a mandatory role, you don't get them at all. If there are no mandatory roles or combinations of mandatory roles that tell you are of that subtype, you get that. Now, one of the interesting things in NORMA is, or actually it's ORM specified, it's not specifically NORMA, is these mandatory constraints kind of show up behind the scenes. So in ORM, if an entity type is declared as independent, it means it can exist on its own. If it's not independent and plays no mandatory roles, then there's an implied mandatory constraint. So all of the roles have a disjunctive mandatory implied across them. So the difference between an objectified unary and a subtype is the objectified unary can be independent, which means if you don't put is independent true, we'll create the implied mandatory for you. That is not true on a subtype. A subtype with ORM theory cannot be marked as independent, so you never get an implied mandatory. Okay, so although they map similarly, you'll see these subtyping columns show up a lot more on simple subtypes, specifically that don't have mandatories on them, simply because you can't mark them as independent. Okay, I'm going to go jump into the tool and show you the difference here and see what happens with the columns. So on the unary objectification, this subtyping column, it's the same pattern, essentially just falls back and becomes the unary column. However, if you have an objectified unary and has a mandatory role on it, you don't actually get a value for that unary state at all because it's implied, just like the subtype would be implied. It's an implied Boolean state and you don't need it. So if you see them paired on an objectified unary, it's actually come full circle. It says, well, okay, here's this type. The type is not implied by anything mandatory, so I need to add a flag. And then it comes back and says, well, I might as well use the same naming and the same structure as the paired unary column, and it may even repair them. But it gets there by a totally different way. So once you objectify it, it's treating it as a subtype or as a one-to-one relationship with the parent table instead of just a column, right? Now, obviously, if you want these columns in separate tables, you can do that as well. That's not a problem. So I'm going to show that in the tool, and that will be the last one for this presentation. I've kept long enough for an overview. So let's compare what we get with a subtype versus an objectified unary. We'll start with the subtype to see the basic piece here. Let's do a get into the fact editor, create a sub action. It's the old command, Control Enter, and go ahead and create a subtype here. Okay, so just with this state, you can get a new column, right? This would not have been here before. So is allowed, we're expecting from the unpaired unary. Is subaction is a new column. Okay, and let's see how long that maintains. So right here, let's just put a description on it. As description and let's give you a quick alignment. Let's add a mandatory, not a mandatory, a uniqueness here. And here we want a data type for it. Let's just put a variable length, give you some space for your description. Okay, there we go. So now if we go to the relational view, I have is subaction is still there, as is the subaction description. They're both there. Why? Well, because this is not implied mandatory because it's a subtype, and is independent is not available. Okay. However, if I make this mandatory, you will see in the relational view that the is subaction column goes away. In fact, you can see that also if I go ahead and put the absorption choice to separate. Now my relational view will show that as a mandatory column, right? Because I made it mandatory. Okay, so let's just take that back. We're going to remove the mandatory, and let's go ahead and put you back on absorb. And we're essentially going to do the same exercise with the unary objectification. So here I'm going to objectify the fact type. I'm going to say allowed action. And now I'm going to see exactly the same column that I saw before, right? Is allowed. Okay, now let's put something on this. Let's go to priority on allowed action only. Okay, there's your priority. And here's your priority there. Let's make a uniqueness. Line those puppies up. Let's give you a data type, numeric, sign integer. Okay, so you'll see this actually gives something different, right? Allowed action priority, there is no is allowed, right? In fact, if I click that and separate, you will see that the priority is mandatory, which corresponds to there being no is column on that, right? Put it back into undo to put it back in, and if I now make this is independent, now of course since it's independent you expect to have the is allowed is back on there, right? So is allowed true. Let's go ahead and give this a negative reading as well. Is disallowed. Okay, so now I have the negated reading on there. I have the negated fact type. And let's see what we have. Allowed action is independent. Let's set it not independent. So if it is independent, our column is going to be Boolean instead of true, right there. If it's not independent, okay, that implies this is mandatory. And let's see what happened to our column. Okay, now I no longer have an is allowed column. I just have the is disallowed, which corresponds to the negated state, but the negated state is no longer paired, so it uses the negation reading, and that can be true. Okay, so you see those are slightly different, and you have to be aware of that. This is actually kind of, I don't want to say bypass subtypes so you can get independent support, but if you really want independent behavior, then just objectify the unary. and you'll get the same mapping. Okay, so that's technically the last thing to show you. I've got one more small topic, and then I'll conclude this presentation. So the unary pattern change is a one-way street. You're not going back. It's not going back to the binarized form of the unaries. There will be potential pain points moving forward. I've done my best to minimize those by when importing with exactly the same pattern. So you import an old structure unary, it maps it to a true-false unspecified, so you get a unary negation fact type, whether you want one or not, simply so the mapping is the same. I strongly suggest after you see the message that, hey, I've got the new NORMA, which will include a link to this video along with the instructions, etc., that you get into the model browser, expand fact types. It's very easy to pick out the unary fact types and go down and just review them. Figure out, what do I want? Is this true false? Is it true null? Is it true false unspecified? Is it came through? What do I really want? And then go ahead and set your unary patterns accordingly. Add additional readings if you want to. Just go through and give it a workover. Now, clearly, I'd recommend that you have your DDL under source control. So there may be other changes in here. For example, dealing with absorbed subtypes, some of the reactions change. You'll get new columns for its subtype columns. And obviously, if you change the unaries, you're going to get different mappings on that. There may be a little bit of work on data migration. So if you have a Boolean column that changes to a true only Boolean, you may want to make sure that it doesn't have nulls. And if it doesn't have false values, if it does have false values, change them to false values, and then update the column definition to match. That should be pretty easy to do with a git diff on the DDL. So I hope it's worth it. I think this is a much more powerful mechanism. It's certainly better from a logic perspective. It was not an easy change. This has been a multi-month change and touched 250 odd files across multiple code bases and Git repos. So I'm glad it's done. I wish I'd done it a long time ago. And hopefully I won't be white before I make another big change like this. And we can get NORMA really clean. There are a couple other small issues that will have a similar impact, but they impact a much smaller subset of models. So thank you. Have a good day. Bye-bye.